Hello DP2 Math AA students. So today we are going to look at partial fractions. How are we going to work with partial fractions? So partial fractions is looking something like this. So can you see they are written separately, and then we can always combine them. We can always combine them by using the rule of adding and subtracting fractions. So basically we are multiplying the denominators, and then we are cross multiplying, and then going to the partial fractions. So the partial fractions can be written as a single fraction, or from the single one we can go into the partial fractions. It's just breaking that down. Okay, so some few important things that we have to keep in mind. Before writing a fraction into a partial fractions, we first have to make sure that the fraction is a bottom heavy. That means the degree of power of the variable is higher in the denominator. For example, if you look at this, 2x plus 1 upon x minus 1, x plus 2. On the top, my highest power is 1. At the bottom, when I expand this, it will become x squared. The highest power will be 2. Therefore, it's a bottom heavy function, right? Another example, let's look at this. This is x cubed plus 1 and x into x plus 1. Here the highest power is 3, and in this the highest power is 2. So this is not a bottom heavy function. So cases like this, to make it a bottom heavy function, we have to use long division and then work. But for you, we are normally looking at the cases when it is already a bottom heavy function. The denominator must be in the factored form. This could be the denominator are the three different cases that we will be looking at today. It's already in the factored form, either looking like that, the denominator of that partial fractions, right? And or we have a repeated linear, anything that's repeated, cases like that. And are non-factorable coordinates. We cannot factorize this. We haven't learned. We can't be using difference of squares or anything. So it's a non-factorable. We are going to look at all these three different cases. So let's look at the first case now, when we have it as a bottom heavy function. Right? Okay, so bottom heavy, in this case denominator will be in linear factors. For example, that's our question. 2x plus 1 into x minus 1, x plus 2. We have to write that as a partial fractions. Okay, before we move on, let's go on with our checking. Is it a bottom heavy? Yes. The denominator is in the factored form? Oh yes, it's in the factored form. Then we will work on to it. Okay, so 2x plus 1 into x minus 1, x plus 2. We are going to give a numerator separately for each of the factored denominator. For example, for this case, a upon x minus 1, b upon x plus 2. Where a and b are the constant terms that we have to find, right? Okay, let's proceed on to that. Okay, so now we have 2x plus 1 upon x minus 1 and x plus 2. The way we add or subtract fractions, multiply the denominator, and then we have to cross multiply, and then we'll be ending up like this, a into x plus 2. I'll just go back to explain that again. There, I'll draw the line, so and then I will cross multiply. Okay, right. So since we have written that like that now already in the multiplied form, and you can see that denominator and that denominator is same. So since the denominators are same, we can get rid of the denominators and then just work with the numerators, right? There. So therefore 2x plus 1, and that's the numerator that's left. Okay. So we have to substitute a value. The values that will be substituted, we will be substituting something so that my bracket becomes 0. What will I substitute in place of x here? That this bracket becomes 0. I'll substitute 1. What will I substitute there? I'll substitute a negative 2. So that my bracket becomes 0, and anything multiplied to 0 will be equal to 0, and it will eliminate one of the variables for us to use. Right? Next, we will substitute x is equals to 1. So 2 into 1, 1 goes there and 1 goes there. You will see this will end up as 0. So I'm only left with this. 1 plus 2, 3a. And then I'll get rid of this 3. My value of a is 1. Next, x is equals to negative 2. 2 into negative 2 plus 1. is equals to, when I substitute negative 2, you will see this bracket is going to be eliminated, right? B into negative 2 minus 1. I have negative 3b left here. And then get rid of the negative 3, value of b is 1. Therefore, when I substitute this value of b and the value of a in my equation, my partial fraction is done. So 2x plus 1 upon x minus 1, x plus 2, that will be equal to 1 upon x minus 1 and 1 upon x plus 2. On this side, I have a 2x plus 1 and x minus 1 into x plus 2. Right? So that's my final answer, how that partial fractions, the case of the factored form, was given.